Hi, this lesson deals with the third method of solving quadratic equations, and it's known as the method of inspection. And as the name suggests, it involves inspecting an equation and generating solutions from the observations made. But before delving into the actual procedure, some introductory concepts need to be understood before proceeding into the actual procedure for using the method of inspection. Firstly, when you have two negative numbers, their product is always positive. So this box just contains the sentence that says for two negative numbers p and q, p times q is always greater than 0. And as you know, any number greater than 0 is positive because the numbers greater than 0 are 1, 2, 3, 4, 5, 6, and so on up to infinity, which is the same thing as saying plus 1, plus 2, plus 3, plus 4. The numbers less than 0 are the negative numbers. So just remember, the product of two negative numbers always gives a positive number. So let's take an example. Say p is minus 3 and q is minus 2. P times q is the same thing as minus 3 times minus 2, which is plus 6. You can try any pair of negative numbers and you always find that their product will be positive. Similarly, the product of two positive numbers is also always positive, and that's what this box says. For two positive numbers p and q, the product p times q is always greater than 0. If you think about it, let's take p as 2 and q as 3. P times q is 2 times 3, which is 6, and 6 is the same thing as plus 6. Try any pair of positive numbers and you'll find that their product is always positive. So just understand that the product of any two negative numbers is always a positive number, and the product of any two positive numbers is always a positive number. You need to remember this, and this needs to be obvious to you as the next letter of any alphabet is. You need to know this very well in order to comfortably work through problems requiring you to use the method of inspection. There's more. What about the product of two numbers with opposite signs? By signs I mean the plus and negative sign. So say p is a positive number, so p is greater than 0, and q is a negative number. What is the sign of their product? Well, p and q will always be a number, p times q rather, will always be a number that's less than 0. So for two numbers with opposite signs, p and q, p times q, the product p times q is always less than 0. Let's try it out. So let's say p is plus 2 and q is minus 3. Product of p and q is plus 2 times minus 3, which gives minus 6. As you can see, the product of two numbers with opposite signs is a negative number. You can try another pair of numbers. So let's say p is now a negative number like minus 4 and q is a positive number like plus 3. The product of p and q is minus 4 times plus 3. We expect this to be a negative number just from this rule, and if you see, when you multiply this out, you get minus 12, which is a negative number. So to just repeat, for two numbers with opposite signs, their product is always a negative number. Further, when you have two negative numbers, p and q, their sum is always a negative number. So say p is a negative number like minus 1 and q is a negative number like minus 3. The sum of p and q, so p plus q, is equal to minus 1 for p plus q minus 3. And this is always a negative number. So in this case, we have minus 4. You can try any pair of negative numbers. So say p is minus 6 and q is minus 10. The sum of p and q will always give us a negative number. In this case, this is minus 6 plus minus 10, which is equal to minus 16. As you can see, this is also a negative number. So that's the first thing. Finally, for two positive numbers, p and q, so p and q are variables that contain only positive numbers, that can only take positive number values. So for p and q being positive numbers, the sum of p and q always gives a positive number. So p plus q is always greater than 0. Let's try some examples. If p is a positive number like plus 2 and q is a positive number like plus 7, p plus q must give us a positive number. In this case, that's plus 2 plus 7. So dropping the plus signs, 2 and plus 7, this gives 9. Try any other set of positive numbers. If p is 20 and q is 100, because p and q are positive numbers, their sum must be a positive number according to this rule. P plus q in this case is 20 plus 100, which is 120. 120 is the same thing as plus 120. So that's all you have to know to really understand, or to be comfortable with the method of inspection. So please ensure you review all the 5 rules that have just been discussed. Now to the method of inspection, which can be applied to any equation of this form, which is a quadratic equation where the coefficient of x squared is 1. That's the only requirement. And for an equation of this form, the method of inspection allows you to rewrite the equation like this. So where the equation of this form, where the variable is x, the method of inspection allows you to write the equation in this way. Just the product of 2 terms, x plus j and x plus k. And from this line, you can write that x plus j is equal to 0, or x plus k is equal to 0. When x plus j is equal to 0, x is equal to minus j. And when x plus k is equal to 0, x is equal to minus k. And if you're wondering how I got from this line to this line, remember the video that discussed the situation where you have the product of 2 variables being equal to 0. The result or the solution of such an equation is as follows: one variable is equal to 0, or the other variable is equal to 0. In this case, the first variable is x plus j, which is set as being equal to 0, and the second variable is x plus k, which is set as being equal to 0. And simplifying, making x a subject of the formula in this equation gives x equals minus j. Doing the same here gives x equals minus k. What is j and what is k? You know that x is a variable of the quadratic equation, but what's j, what's k? Well, j and k are numbers such that the sum of j and k gives b, which is the coefficient of x in the quadratic equation being solved, and j and k are such that the product of j and k gives c, which is the constant term in the quadratic equation being solved. So that's the method of inspection. And the hardest part of the method of inspection is determining the values of j and k, and that's what's going to be visited next. So here's an example of a quadratic equation that needs to be solved, and we're going to apply the method of inspection. The method of inspection applies to equations of the form x squared plus bx plus c equals 0, where, the coefficient x squared is 1. That's basically what this equation states. Our given equation is x squared plus 5x plus 4 equals 0, which is exactly of the required form. The coefficient x squared is 1, and everything else matches. And once this is satisfied, we can proceed to rewriting this equation in the form x plus j times x plus k, where j and k are such that the sum of j and k is b and the product of j and k is c. So b, which is 5, the coefficient of x, is equal to j plus k, and c, which is 4, is equal to the product of j and k. So now we need to determine a value for j and a value for k that meets these 2 conditions. So I'm going to call this equation 1 and this equation 2. So just by looking at a product, and as a piece of advice, it's always a good idea to look at a product for reasons that will become obvious later. Here, the product of j and k is 4, a positive number, which means that, based on the rules, which means that either both j and k are negative numbers or both j and k are positive numbers. Because if you think about it, when you have 2 negative numbers, their product is positive, and when you have 2 positive numbers, their product is positive as well. So j and k are either both negative numbers or either both positive numbers. Looking at equation 1, we can see that the sum of j and k is 5, which is a positive number, and we know that j and k are both positive just by looking at equation 2, just by looking at the product, or j and k, that should be an ampersand sign, are both negative. But which case is it? We want to know. Well, by looking at equation 1, we can tell the sum of j and k is positive. When both j and k are positive, what's their sum? Their sum will be a positive number. According to this rule, when you have 2 positive numbers, their sum is positive. So this is a viable option. When you have 2 negative numbers, their sum is negative. So this can't be the case. So we know now that j and k are positive numbers. So we're just going to guess positive values for j and k to find values that satisfy equation 1 and 2. So let's just rewrite the equation in this form. Equation 1 is now, I'm just rewriting it just like this. I'll just swap the left hand side and right hand side. And jk equals 4. And we know that j and k both positive numbers. I'm just going to represent positive with a symbol positive. By the way, the approach for applying the method of inspection is a trial and error approach. The trial and error approach is basically guesswork, so let's just write guesses. So for J, let's guess that J is 1. Well, you can only guess positive numbers because we know J and K are both positive. So if J is 1, to satisfy equation 1, K has to be what? K has to be 4. And how do you determine this? Well, we know that J plus K must equal 5, which means, so if I do this, J could equal 5, which means 1 plus K must equal 5, which means that K is equal to 5 minus 1, which is equal to 4. So when J is 1, according to equation 1, if you substitute that into equation 1, we get that K is 4. So we have a value for J and a value for K. But let's see if it satisfies equation 1, but let's see if it also satisfies equation 2. If you don't believe that it satisfies equation 1, look at it. We have J is 1 and K is 4. 1 plus 4 is 5. Now for equation 2, let's see what happens. Equation 2 requires that J times K be 4. Our J times K, J is 1 from our first guess, and K is 4, which is 4. So when J is 1 and K is 4, both equation 1 and 2 are satisfied, which means we're done with the guessing. So we were lucky in this case because our first guess gave us the result we were looking for. So just going back to the expression, the original equation is therefore written in this form: x plus J times x plus K. We know what J is, we know what K is, so our equation is now x plus J times x plus K equals 0. And because we have the product of two variables, where this is one variable and this is another, being equal to 0, the result is that either the first variable is equal to 0 or the second variable is equal to 0. This can be simplified to give x equals minus 1. This can be simplified to give x equals minus 4. Therefore, the solution to the original equation is x equals minus 1 or x equals minus 4, where the original equation is this equation here. So just to summarize the method of inspection, you're given an equation. In order to solve it by the method of inspection, you need to first check that it meets this form. Once it meets this form, you can write this expression: x plus J times x plus K equals 0. And you need to determine J and K. And J and K are such that J plus K equals B, which is the coefficient of the x term, or x variable rather, or the variable x, and the product of J and K, so J times K is equal to C, which is the constant term in the quadratic equation. In this case, B is 5, so 5 is equal to J plus K, according to this equation, this one here. And according to this equation, C is equal to J times K, so 4, which is C, is equal to J times K. So now we have two equations, and solving these two equations will give the appropriate values of J and K, but this solution has to be carried out by trial and error and a bit of the logical reasoning. So what we did was say, okay, well, we looked at the result of the product of J and K, and we saw that the product was 4, which is a positive number, and we know that if the product of two numbers is positive, either both numbers are positive or both numbers are negative. We then looked at the other equation, which says that the sum of J and K is a positive number, and we know that when two numbers are positive, their sum is positive, which means that this is this scenario where J and K are both positive satisfies the first equation and the second equation. However, if both numbers, the second scenario, which states that both numbers are negative, only satisfies the second scenario, because when two numbers are negative, their sum is positive. So the sum of two negative numbers can never be a positive number like plus 5. So we got rid of this scenario and said, okay, well, J and K must be positive numbers. Both of them must be positive numbers. So we only, in our trial and error approach, we only took positive guesses for J and K. And our first guess, we took J to be 1. And in order to satisfy equation 1, we replaced J with 1 in equation 1. And this gave 1 plus K equals 5. And K equals 5 minus 1 is 4. Which means that equation 1 is satisfied when J is 1 and K is 4. But equation 2 also needs to be satisfied for the J and K values to be the ones we're looking for. And we tested our first guess, which is j equals 1 and k equals 4, with the second equation. And when we tested it, we found out that, in fact, equation 2 was also satisfied because j, which is 1, times k, which is 4, gave 4, as required by equation 2, which meant that j is actually 1 and k is actually 4. So we wrote our original equation in this form, which is this is the x plus j times x plus k form. That's what this is. And from this expression, we know that when we have the product of two variables being equal to 0, the result is either of the variables being equal to 0, so x plus 1 being equal to 0, or x plus 4, the second variable, being equal to 0. Simplifying, each of these gave x equals minus 1 or x equals minus 4. So our solutions are x is equal to minus 1 and x is equal to minus 4. And if you don't believe, you can test the results by substituting them into the original equation. You'll find that the original equation is satisfied when x is equal to minus 1 and when x is equal to minus 4. You'll find that left hand side and right hand side terms match. So you try that at home. Here's another example. This example says solve the equation 3x squared minus 3x minus 18 equals 0. Now we're going to use the method of inspection, but we know that the method of inspection can only apply to equations of this form, where you have a quadratic equation whose x squared term has a coefficient of 1. In our given equation, the x squared term has a coefficient of 3, which isn't 1. So we need to rewrite this equation so that the coefficient x squared becomes 1. This can be achieved by dividing the equation through by the current coefficient of x squared, dividing through by 3. Doing so gives, so dividing by 3. Doing so gives the equation 3 and 18 is 6, gives x squared minus x minus 6 equals 0. And just to ensure this equation matches exactly as this equation, we're going to introduce plus signs before the minus signs. This is exactly the same as this equation. So this is the equation we have, which satisfies the form for the application of method of inspection. Therefore, we can write this equation as x plus j into x plus k equals 0, where j plus k equals b and j times k equals c. In our case, b, the coefficient of x, is clearly minus 1, and c, the constant term, is clearly minus 6. So this is a minus 6. Let me just improve that to minus 6. Using these rules and formulas, we can now write that b is equal to j plus k. As you can see, b is j plus k, and c is equal to j times k. Call this equation 1 and call this equation 2. So now we need to determine values of j and k, i.e. values of j and k that satisfy both of these equations. Now, just to reduce our workload, let's apply some logic or common sense. If the product of two numbers is negative, it means that both numbers, or rather, it means that the numbers have opposite signs. Numbers have opposite signs. If you recall, when you have two numbers, e.g., when you have numbers with opposite signs such as minus 6 and 3, the result will be a negative number. In this case, that's minus 18. If you had numbers with the same sign, e.g., 2 and 3, you get a positive number. You have numbers with the same sign, same negative sign, minus 3 times minus 5, you get 15. So only when you have two numbers do you get their product to be negative. So now we know that our guesses for j and k must be such that j and k have opposite signs. So let's start our guesswork. Let's try j equals 1. If j equals 1 from equation 1, replacing j in equation 1 gives minus 1 into j plus k, which can be written by swapping the left hand side and right hand as 1 plus k equals minus 1, which, making k the subject of the formula, gives minus 1, which is minus 2. So when j is 1, k is minus 2, just from our first guess. And that satisfies the first equation because j plus k is minus 1 in this scenario, because 1 minus 2 is minus 1. Now let's see if the result j equals 1 and k equals minus 2 satisfies the second equation. The second equation requires that the product of j and k be minus 6. So let's see what happens. J times k is 1 times minus 2, which is minus 2. This does not satisfy the second equation, therefore the result j equals 1 and k equals minus 2 is not a valid result. So our first guess didn't give the valid values of j and k, so let's try another guess. So I'm going to call this trial guess 2. Let's try j equals 2. When j is 2, from the first equation, replacing j with 2 gives minus 1 equals 2 plus k, and allows us to determine a value of k which satisfies the first equation. This gives 2 plus k equals minus 1, making k the subject formula gives minus 1 minus 2 is minus 3. So we have j is 2 and k equals minus 3 just by considering values of j and k that satisfy this first equation. I mean, if you look at this, if you replace j with 2 and k with minus 3 in the first equation, you get 2 minus 3, which is minus 1. So the equation is satisfied because the left hand side is equal to right hand side. So you can try doing it yourself. Replace j with 2 and k with minus 3 and see if the first equation is satisfied. However, the valid values of j and k satisfy both this equation and second equation. So we need to test the second equation. Is the product of j and k equal to minus 6? Well, let's see. J times k is equal to 2 times minus 3, which is equal to minus 6. Therefore, the second equation is also satisfied. Therefore, j is actually equal to 2 and k is actually equal to minus 3. So our original equation, which is 3x squared minus 3x minus 18 equals 0. Obviously, that's all being blocked out, which we simplified to x squared minus x minus 6 equals 0, and also to this, can now be written in this form. We now know what j is, and we also know what k is. So doing that below gives we now know that our original equation can be written in this form. Using our determined values of j and k, we can write x plus j, which is 2, and x plus k, which is minus 3, which gives x plus 2 to x minus 3. And we know for situations like this where we have the product of two variables being equal to 0, the solution is the case where either the variable equals 0. So either x plus 2 equals 0 or x minus 3 equals 0. So for this case, we get x equals minus 2. For this case, we get x equals 3. So the valid solutions are x equals minus 2 and x equals 3. So if you don't believe that these are valid solutions, try substituting x equals minus 2 into the original equation and see if the equation is satisfied. Also do the same when x equals 3. And you find out they actually do satisfy the equation, hence why they are the solutions to the equation. Here's a final example which asks for the solutions to this equation: minus x squared minus 6x minus 8 equals 0. Now, by now you know that the method of inspection applies to equations of the form x squared plus bx plus c equals 0, where the key thing is that the coefficient of x squared is 1. In this equation, the coefficient of x squared is minus 1, because this whole equation can be written as minus 1 x squared minus 6 minus 8 equals 0. As you can see, the coefficient of x squared is minus 1, and that's the key trick in this question. So in order to apply the method of inspection, the coefficient of x squared needs to be made 1. This can be achieved by dividing through by the current coefficient of x squared, which is minus 1. So you can divide through by minus 1. But another approach would also be to multiply the equation through by minus 1. Multiplying through by minus 1 or dividing through by minus 1 gives x squared plus 6x plus 8 equals 0. So just imagine this equation. Imagine dividing through by minus 1. You get there 1. Divide this through by minus 1. You get plus 6. Dividing through by minus 1. The minus sign just cancels out really. and dividing through by minus 1. 0 divided by minus 1. 0 divided by any number is 0, so this is what we have. So this is what we have as our equation. It meets the form for the application of method of inspection, so we can go ahead and write it in the form x plus j times x plus k equals 0. We know that b is the sum of j and k, while c is the product of j and k. So we need to determine values of j and k that satisfy these equations. Here we know that b is 6 and c is 8, so 6 must be equal to j plus k, and 8, which is c, must be equal to the product of j and k. Equation 1, equation 2. The values of j and k which satisfy equation 1 and 2 are the valid values of j and k. So now we just want to find valid values of j and k. By looking at equation 2, we can see that the product of j and k is a positive number, and we know that that means that both j and k are positive, or both j and k are negative numbers. When we look at equation 1, we see that the sum of j and k is a positive number, plus 6. If j and k are positive, can their sum be positive? Yes. If j and k are negative, can the sum be positive? Because here we have a sum of 6. Can the sum be positive in j and k? Both j and k are negative? No. That means j and k must both be positive numbers. So our guesses for j and k will only be positive numbers. Doing this helps us reduce the amount of time we spend guessing in the trial and error process. Now to the guessing. So let's have our guess 1, our first case. Let's try j equals 1. When j equals 1, replacing j to determine the corresponding value of k that satisfies equation 1, replace j with 1 in equation 1, and this gives 6 equals 1 plus k, because j has been replaced with 1, which can be simplified as follows to give k equals 5. So now we have a result, j equals 1 and k equals 5. Now let's see if this result satisfies equation 2. Well, equation 2 requires that the product of j and k be 8. J times k, using these values, is 1 times 5, which is 5. It should be 8, therefore this result is not correct. So let's try another guess for j. Let's try j equals 2. Replacing j equals 2 in equation 1 gives 6 equals 2 plus k. Why do I replace j with 2? I do in equation 1. I do so because doing that gives a value of k that satisfies equation 1, as you will see shortly. So making k the subject of formula gives k equals 6 minus 2, which is 4. So now we have a result, j equals 2 and k equals 4, which satisfies equation 1, because if you look at equation 1, when j is 2 and k is 4, 2 plus 4 is equal to 6. So equation 1 is satisfied. Now to see if equation 2 is satisfied for those results, equation 2 requires that the product of j and k be 8. When j is 2 and k is 4, what's the product of j and k? That's 2 times 4, which is 8. Therefore, as you can see, j and k satisfy, j equals 2 and k equals 4 satisfies both equation 1 and 2. Therefore, these are the valid values. Therefore, the original equation can be written in the form x plus j times x plus k equals 0. And remember, when you have an equation involving the product of two variables, the result is obtained by equating each of the variables to 0. Now we know that j is 2, we have x plus 2, and we know that k is 4, we have x plus 4 equals 0. So we take x plus 2 equals 0 as one result, or x plus 4 equals 0 for the second result. Simplifying this gives x equals minus 2, simplifying this gives x equals minus 4. Therefore, the solutions to the original equation were given as follows: x equals minus 2 and x equals minus 4. Now try substituting these results into the original equation, and you will find that the equation is satisfied. The left hand side will match the right hand side, hence why x equals minus 2 and x equals minus 4 are the solutions to the given equation.